Hey everyone, welcome to day one of the 2025 Everybody Codes event, the Song of Ducks and Dragons. Originally, this was going to be a live stream because we are allowed to stream the contest problems in real time. Unfortunately, I forgot how to stream on YouTube. As it turns out, you need to hit go live in YouTube after you hit start streaming on OBS, so good to know for tomorrow, I guess. Let's just look through the problems in post. I don't want to bother trying to gather an audience to stream again, so I'm just going to record this and upload it as a video. So looking at today's problem, our input is a list of names and a list of directional instructions. Each instruction gives us a direction right or left, and then a number indicating the number of positions to move right or left from our current position. So it looks like we're trying to figure out what our own name is. And so we start at the first name in the list. So in the first part, the description tells us that if we can't follow the instruction without going off the edge of the list, we do as many moves as we can and then stop at the end. So for example, with this test case, we start at the name Verdax, and then we move to the right by 3, left by 2, and then we try moving right by 3 again, but since there's no name to the right of Elarzarus, we just stop there, and then we move left by 1 to end on the name Firin. These are very interesting names, I must say. So grabbing the inputs for this is not too difficult. We just take a line of input and split it on commas, read an empty line of input, and then get the instructions. In order to track where we are in the list, we can keep track of our current index, and then we can loop through each instruction. The direction is going to be the first character of the instruction. To make things easier, when we're moving right, we're increasing our index and decreasing it when we're moving left. So we can say that the direction is 1 if the first character is R and -1 otherwise. And then the offset will be the rest of the string. I don't know if it'll just be 1 digit every time, but I'm not going to make that assumption if I don't have to. We'll parse it into an integer, and then we'll multiply it by the direction we're moving in. So for example, the first instruction R3 would give us this is true, so the direction would equal 1, and then the offset would equal 3. The second instruction L2, the direction would be -1, as this character is not an R, and then the offset would be -2, meaning we're moving to the left. And then we can do index plus equals offset to move the pointer, and then we can see if we're off the end of the list. So if we're too far left, the index will be less than 0, in which case we can just set it to point to the first element in the list. And if the index is greater than or equal to the number of names in the list, we know we're too far right, and we can say index equals the number of names -1. And then at the end, we can just print out the name at the index. And that should give us our answer for part 1. And if we run this on our actual input, we get our answer of, I'm not even going to try to pronounce that, I'm going to be completely honest. Moving on to part 2, fairly straightforward continuation. Rather than the names being in a list, they are now in a ring, and we can move around the circle. Essentially, instead of stopping when we reach the end of the list, we just wrap around. That's honestly easier, as instead of clamping the index to the size of the list, we can now just take the remainder relative to the number of names. If you're not familiar with the %sign moderator or operator, it's known as modulo. You can think of it as the remainder of the left side divided by the right side. So for example, if we have 5 names and the index is 7, then 7 modulo 5 is equal to 2. And so that allows us to circle around the list. So for example, if the top is index 0 and we're trying to get index 6 in this list, we go 0, 1, 2, 3, 4, 5, 6 to get the name Firin. And so if we take 6 modulo 4, which is the number of names, we get an index of 2, which works out to Firin as well. And so that does fine for part 2. And then for part 3, instead of moving around the list, we are now swapping names with the top of the list. So this time we're still in a closed loop, so we still need to modulo by the length of the name list. But rather than having a pointer and moving around the circle, now we look at the name relative to the top in the offset and swap places with the top. So in the example here, R3 points to Elarzaris, and instead of moving to Elarzaris' position, we switch Verdax and Elarzaris in the list, and so on and so forth, each time staying at the top. So now, rather than having an index that we maintain and adjusting it by the offset, we are switching its place with names 0. So essentially what we want to do is switch names 0 and names offset. And fortunately, this is very easy to do in Python. In Python, if you want to swap the value of two variables, you can just do x comma y equals y comma x. The way this works is we take the value of y and x, bundle it into a tuple, which is basically an immutable list, and then we unpack it on this side and assign y to x and x to y in parallel. So doing something like this would not work because we would first change the value of x to the value of y, which means that in the second line x already equals the old value of y, so we'd end up with both x and y equal to the old value of y. However, when we assign in parallel, neither of these operations happens first. We evaluate both of these and then bundle them together, which means that we can simply do this to swap our names. Or if we want to save, we can save a bit of space here and do the modulo here. So we can just do names 0 and names offset equals names offset and names 0. And so this switches the top of the ring with the name at the offset. And then finally we just want to print the name at the top, so we just print the first element of our names list. And so running that for part 3, we get our answer. So relatively straightforward problem for day 1, pretty interesting and pretty excited to see the rest of the problems for this year. And I'll catch you in tomorrow's stream. Hopefully this time I'll actually remember how to live stream. Thank you for watching.